Hello everybody, and welcome to my tutorial on the Erlang programming language. I have written up this entire code for the purpose of showcasing and demonstrating various functional properties specifically within Erlang, including pattern matching, recursion, guards, lists, and what was it called again? Yes, list filter. Sorry about that. Yeah, each of those functions all within Erlang. Now, Erlang is a bit different from most other programming languages because while other ones like Python and C++ are considered object-oriented programming, Erlang is considered to be more functional programming. So as a result, it's going to sort of work differently here, and I'll show you why that's the case. So the first thing we're going to do is pull up the terminal on the bottom. I think right now it's running Windows PowerShell, but if I type ERL and then enter, then suddenly it will open up a compatible Erlang terminal so that I can run this code. Um, so now I'm going to compile the code by using C and then typing in the name of the file, so module 03 in parentheses, and then a period at the end, because in Erlang you will always want to put periods at the end of everything. And then hit enter. So right there it just says OK module 3, and that means that it's worked. So this entire code is now compiled into another file over here, module03.beam. Now I'm not able to pull this up, but essentially this is the executable that the terminal will now refer to anytime I call something. So as you can see, I'm not able to just run the whole code and then have everything output all at once, like in other languages. Instead, I will have to call each function individually from within the Erlang terminal. So now, as we go down this code, right here I have, basically you're going to want this line and this line right here at the beginning of every single Erlang file. This line right here will declare the name of your file as a module so that the compiler can recognize it. If I didn't have this, I wouldn't be able to compile this code into the .beam file over here. And then right here, I have every single function called with the purpose of being exported. Without this line, none of these functions here that we will get to will be run. And as you can see, I have them all listed out with the function name and then a forward slash and then a number. And that number is supposed to represent how many parameters that function is supposed to take. So if I were to come all the way down here to display, you'll notice there are no parameters here, hence why it's just 0 over here. Now there is another thing that you can do where instead of just like listing all of your functions individually, you can just hit hyphen compile and then export all within parentheses, and that's supposed to tell the code to export all the functions that it recognizes as functions anyways. But most places that I found while looking up example code for creating this program all did not recommend at all the use of this. It's just very prone to bugs. So I have it here commented out so I can talk about it. But as far as exporting all the functions, I will be using this traditional method. So now we're going to start with a basic display. Like I said before, not all the functions could just run immediately, and you can't just like have a normal print statement. Instead, you have to have the print statement put into a function, and then you have to call that function in the terminal. So right here, I have a function called display, and I'm going to have it output this statement right here. So the way we're going to call this is by first typing in module03, so the name of the file, and then a semicolon, and then the name of the function we want to call, so display, parentheses, and then period. Enter, and as you can see, it managed to output it. I completely forgot to put tilde n right here at the end, which is supposed to start a new line. And so as a result, it outputs OK at the end of the statement as if it was part of it instead of down here. But then again, I suppose the sentence, if you can read me, then the function is working okay, makes just as much sense as if you can read me, then the function is working. So I suppose it is no big deal. But yes, the terminal will be outputting okay down here, basically at the end of everything that you call. So now we're going to another one. It's kind of similar, but this one will ask for user input. So let's call this one now module 3, semicolon, user input. Yes, I spelled that correctly. Period. Okay, enter my age. I am 24 years old. And I also figured out the hard way that you do want to put a period at the end of this as well. In 20 years, you will be 44 years old. So as you can see, I have it written right here where it has a user input statement in the form of io:"read" instead of io:"format. And then I had it go enter your age. And then right here is where I set the variable of age that then gets saved to whatever the user types in. And then down here, I have the output statement. In 20 years, you will be tilde-w, meaning right here is where we will have the next variable just put in. So age plus 20. So in the output, it reads as 44 instead down here. And then this time I made sure to include the tilde n so that OK appears outside of the statement. All right, so next we're going to talk about pattern matching. And this is sort of another unique mechanism, I guess you could say, to Erlang. I guess the best way I can do it is just show you. I don't know how to explain it and do it justice without doing that. So we're just going to go right into calling this function right here first. Okay, perfect. Get rid of user input there. Okay, now this one, we actually do have parameters that we do want to input. So as you can see, this is a list. You can tell because of the square brackets. And it has exactly 4 things in it. Yeah, exactly 4 terms in it. So basically, you have X right here, the first one, and then I just have empty, what are these called? Underscores. Just empty underscores here for the second, third, and fourth parameters. Now, it's important that you put this little, like, column character. I don't know how to describe it. On a keyboard, you would find it, like, if you hit Shift / right next to where you find the square brackets. It's important that you put this right before the final term in the list whenever declaring lists like this. So as you can see, X is the only one that fills in a parameter slot, and that would be the first one, and then I have it just output X. And basically what that means is with this one, we want it to, or this function is only going to output whatever you put in as the first parameter right here. So as I'm calling this, we'll just put 1, 2, 3, 4 as the inputs in the list, period. And then when we run it, oh no, I put 2 periods. I messed up. Okay, yeah. Good, I got it to restart. User input display. Okay, this time let's actually do it correctly. First, parenthesis, square bracket, 1, 2, 3, 4, square bracket, parenthesis, 1 period. All right, perfect. So as you can see, it outputs just 1 because that was the term I put in here. Now, if I were to call this again, but give it different parameters, like instead of 1, 2, 3, 4, let's go 3, 6, 9, 12. This time I outputted 3 because the function is supposed to return the first in the list, and down here when we were calling it, we inputted the first thing in the list as 3. So now let's move on to third, and in this third one, once again, just like the first one, it exists to output the third term instead of the first. So Call it again, but this time let's replace the function with third instead of first, and then we hit enter, and this time it outputs 9 because 9 is the third term in this list. So that is a somewhat basic example of pattern matching, but now let's move on to a more advanced one. Down here I have another function called equal, where it takes two parameters and then it will return an output based on whether or not those two parameters are identical. So calling this module 3 colon equal, let's do 5 and 5. That is not what I want to do. Okay, period, enter. It outputs true because 5 is indeed identical to 5. If I was to do this again, but instead replace the second 5 with a 6, suddenly it's false because 5 and 6 are not equal. So it's looking at that and it's using its pattern matching functions to essentially release the outputs that it wants. So hopefully this explanation is able to help you understand what pattern matching is all about in the context of Erlang. So now we're going to move on to recursion. Just like every other language, recursion refers to a function that calls itself over and over again up to a specified number of times. And I have right here one function known as rec, which is supposed to be the recursive function that will reiterate through a list over and over again until, yes, with each one like counting down from how big the list is. So down here we have more functions that we're going to use to call rec. As you can see right here is where rec calls itself, where so long as it has parameters to call, it will call itself over and over again, add 1 to the whole thing until it reaches nothing. And when it reaches nothing right here is when it's just going to output 0 and it's going to stop calling itself. So now here's one example of how we're going to call rec, but have a separate function input the parameters for us, as well as give us a print statement. So down here in the terminal, we're going to type module 3 begin 1. Also, I figured out the hard way that begin is apparently not a valid name for a function in Erlang. For whatever reason, it doesn't like it, so I guess it must be something preset that's useful for something else, like how you can't just name a variable true with a capital T, because programs will recognize that word as the Boolean output true. So yeah, begin has some hidden function in Erlang that I have yet to figure out. But anyways, I'm getting off track here. Let's just call begin 1 and see what happens. So it outputted 4 because, like I said before, the whole point of this was to reiterate through every single item in the list and then output how big that list is. So with begin 1, I have a list of the numbers 1, 2, 3, and 4. And then when I call it, it outputs the number 4 because that's how big the list is. So now if I were to run begin 2, which will call upon the same recursive function from earlier, it outputs 5 because now the list is 5 characters long, 2, 4, 6, 8, and 10. Now we're going to move on to another recursive function, and this one is going to allow us to input 2 parameters, and the first parameter is going to just be a single integer, and the second parameter is going to be how many times we're going to duplicate or create a clone of that integer. So just like the last one, I have right here the clone function that if at any point its integers become empty, it then just returns nothing and stops calling itself. But then down here, we have the other one that actually does do stuff, assuming there are integers. And also, notice right here, I have placed what's called a guard. In other languages, it's possible to rewrite if statements so that instead of being written like if this then that, you can write them like do this if this condition is met. And that's basically what's happening here in Erlang. It uses this guard right here to say that this function is only going to be called when this parameter is fulfilled, that being whatever value being assigned to b is greater than 0. And with recursive functions, most of them usually will require a guard of some sort, because without them, there's a good chance that your recursive function will just call itself infinitely over and over and over again until your computer runs out of memory and crashes. And that is not a thing you ever want to have happen for obvious reasons. Um, so, anyways, down here I have yet another example of this, begin 3, where it calls the clone function and it puts in the parameters of 6 and 3. So we're going to run that in 3. And as you can see, it does indeed output 6 3 times, and even restructures it into its own separate list. The infamous number of the beast, for those of us who are familiar with the New Testament. Anyways, so now we get to the last one that I will be demonstrating here today, and that is the form of this function that you can actually just pull off within the terminal itself. So I knew going into creating the software that Erlang would require me to call all of its functions within the terminal. But what I didn't know was that you actually could do stuff in the Erlang terminal without even having a code brought up, or without even having a .beam file to bounce off of. And I'm going to demonstrate that right here with this specific function known as lists filter. Notice this time around I didn't have to call module 03 because I won't be taking anything from module 03.beam. Let me just write all this out really fast. Make sure I don't mess anything up. I apologize for being a slow typer, but oh well, it is what it is. Ooh, not that much, not that much. Definitely don't want that much. Okay, so basically what I have typed out here is a list.filter function where I have the function called right here, just a pre-built function within Erlang. And then right here, I have a separate function variable that is left anonymous and empty so that it can be filled with essentially what's going on right here. Or actually, it gets filled with what goes on right here with list seek, or sequence, SEQ. I don't know how else to say that. And right here, we have the condition, where essentially what we're going to do here is we created a list of all the numbers between 0 and 300, and that's what sequence is. It's a sequence that starts with 0, ends with 30. So not 300, I meant 30. And then I have right here, it's going to output every single number that isn't divisible by 3. Probably put a space right there. There we go. It's going to output every single number that isn't divisible by 3 into a new list. So I'm going to enter this. Oh, hang on. What did I do? Oh, okay. I see what I did wrong. Yet another thing I didn't put a space in. Now we're going to. Oh, now. Just like writing real code, you have all sorts of little things you have to account for when doing things. Okay, is it going to work now? No? It was working earlier. What is going on here? Okay, hang on. I'll be right back. All right, so I figured it out, and it was just because I had accidentally put a lowercase x right here as the variable. And in Erlang, you will basically want every single one of your variable names to start with a capital letter. And because it wasn't, it was re- it was rendering both the lowercase x and the capital X as two different things, and therefore thinking that this x right here was unbound. But now that I have gone and fixed this little function right here, and by fix I just mean call it over and over until I find what's wrong with it. Now that I have fixed it, it finally was able to output what I was looking for. So as we can see, we have a sequence of all numbers between 1 and 30, but with all numbers that are divisible by 3 completely removed. So now let's try this again, but let's use other parameters. Like maybe, what if it was every number divisible by 2 removed from a sequence of numbers from 0 to 10? 1, 3, 5, 7, 9. A much more boring list than the previous one. In that case, what if we did 5 and 25? Yep, numbers 1 through 25, but all numbers divisible by 5 removed. Um, so yeah, that right there was just a little demonstration that you indeed can just create your own things and then just have Erlang itself run it for you in the terminal. And as you can see, I didn't have to call upon module 03 at all. So I didn't even need a code to call it from. I could just run it right here in the terminal. So yes, this has been my Erlang tutorial. I hope you all have a good day.